Hello everyone. Today I am going to discuss the fifth problem of Codeforces round 954 division 3, which is beautiful array. So we are given an array of integers a1 till an and an integer k. We need to make the array beautiful with the least amount of operation. Before applying operations we can shuffle the array, and after shuffling we can choose any index and make ai as ai plus k in one operation. The array b1 to bn is beautiful if bi equals to bn minus I plus 1. That means the b, if the b array is a palindrome, then you can say that the array is beautiful. Okay, find the minimum number of operation needed to make the array beautiful, or report that it is impossible. Okay, so the let's take this test case. Okay, third test case, this is 3 to 1. Okay, third test case is 3 to 1. Let's take that one. 3 to 1. Okay, now 3 to 1, what is the operation we have to do? We can shuffle the array to 2 3 1. We can shuffle the array to 2 3 and 1. Okay, and we can increment this value by 1, so the array will be 2 3 2. 2 3 2. This is one possibility. The total number of operations here is only 1. This is the desired answer, but the other possibilities are like increment this value by by 2 times, so that will be 3 2 2, and after that it will be 3 2 3. Here the number of operations is 2, so this is not the desired way to solve this. Okay, another possible way to shuffle this is 1 1 3 2, like the reverse of this thing, and just increment this value by 1. This will be 2 3 2. Here the value of k is 1, that's why we are incrementing this value. Now here comes the observations. Interesting observation. First interesting observation is that, let's say we are trying to equal ai and aj. We are trying to equal ai and aj. There is a specific condition such that ai and aj can be made equal. What is the condition? That we are doing ai to ai plus k like this till aj. Okay, so we can say that aj minus ai is something like p into k. P into k for some positive integer p. If aj greater than equals to ai, then this condition holds. Aj minus ai is p into k. That means aj minus ai is divisible by k. Aj minus ai is divisible by k. That means if we take modulo, then we can say that aj modulo k minus ai modulo k is should be 0. Then the condition is that aj modulo k should be equals to ai modulo k, right? This is the condition. Now let's say we are grouping the elements based on to this ai modulo k value. We are grouping the elements based on to the ai modulo k value. How we can group them? Let's say some group has like these elements. Let's say mm, ai modulo k, let's say some group has this value 1, let's say 1 3 5 1 3 5 and 7, and let's say k equals to 2. So k equals to 2, and the array is 1 3 5 7, because 1 modulo 2 is 1, 3 modulo 2 is 1, 5 modulo 2 is 1, and 7 modulo 2 is also 1. So let's say this is one array. Now for this array, how we can make this, like we have to like create two pairs from this array. We have to create two pairs that are equal. So what is the optimal way to choose pairs? The optimal way to choose pairs is obviously to equal two neighboring elements. So we are trying to equal these two elements and these two elements. This is the optimal way to equal two elements. Okay, so we'll increment the value of this by 2, so it will be 3, and increment the value of this by 2, this will be 7. So the total number of operations here is nothing but 2. Okay, so for every set ai modulo k value, we will create one set. Okay, create one set, and in that set we will try to create pairs of equal elements. We will try to create pairs of equal elements, and the optimal case to equal elements is that to select neighboring elements and make them equal. Okay, I hope you get it. Now for the even case this is quite straightforward, but for the odd case, here comes the trick. For the odd case, this will be difficult. Let's say we have something like 1 3 9 and 13 and 15. Let's say we have something like 1 3 9 13 and 15. Now we can't really make pairs. We can make two pairs, but there will be only one element left. There will be only one element left. Now here you can see that the optimal way to choose is that this pair and this pair. Okay, we optimal way to choose the first two elements and the last two elements, but this will not obviously the case always. So let's say we are selecting 1, 13, 15, 17 and 19. Here the optimal way to choose pairs and like this 13 to 15 and 17 to 19. Okay, I hope you get it. And there could be other cases also. So how we can solve this? We will try to remove one element. Let's say we will iterate over all the elements and we will try to remove a specific element. We will try to remove a specific element and try to form pairs in the left side of this element and try to form pairs on the right side of this element. Try to form pairs on the left side of this element and we will try to form pairs on the right side of this element. Now one thing to observe here is that the elements we are deleting should be at odd index. The elements we are deleting should be at odd index, because if not, then we can't can't create pairs on the left side or right side. There will be other elements also. So we'll select one element that to be deleted and we will select the value in the left range and we will select the value in the right range. We can do some kind of prefix sum to store the prefix array and we can do some kind of suffix sum to store the suffix array. Let's say this the prefix value here will be 2 and the suffix value here will be 2. So our answer will be prefix of this and suffix of prefix of I minus 1 and suffix of I plus 1. 2 plus 2 4. Now here is another important part. Here when the answer is minus 1, when the answer is minus 1, the answer will be minus 1. Let's say we have built some groups, right? We have built some group. Let's say the first group contains three elements 1 3 5, and let's say the second group also contains three elements 0 2 and 4. Okay, so we are creating one pair from this and one pair from this, but there are two elements left. So we can't make palindrome. Let's say there are five elements. There are five elements like 3 3 9 3 3 will be a palindrome, but here two unequal elements are present, so we can't really make palindrome. Okay, I hope you get it. So if the number of odd sets are greater than 1, then the answer will be minus 1. Otherwise I have explained the algorithm for the even count set and the odd count set, and let's jump onto the code. You will understand the solution better. Okay, so here we are adding AI modulo k will be the set key of the set and AI will be the value. So we are taking AI modulo k and adding AI in this set, in the key. This is the key and this is the value. We will be adding this AI in the set and let's say AJ in the set, like that. Okay, and after that we will iterate over all the keys in the set. We will sort the value, sort the array of the specific key, and if the length is odd, if the length is even, let's come to that. If the length is even, we will iterate over all the elements and we will take two adjacent elements and take their difference and divide it by k. That will be the number of operations. Okay, now for the odd elements we will increment the odd value by 1. Now if odd is greater than 1, then the answer will be minus 1, obviously. Otherwise this is the answer. Now for odd element we are creating one prefix array. Now for every index we will iterate over this index. We'll iterate over this index, and for this value we'll select 3 minus 1 2. We'll print 3 here, and for this value this will be 13 minus 9 plus 2. This will be 6, like that. So prefix j is prefix j minus 2 plus the difference of the neighboring elements by k. Now our result value will be prefix of m minus 2, means that we are rejecting the last element. Then the value will be prefix of m minus 2, this one. The answer will be 6. And now we are iterating over all the odd elements. We are iterating over all the odd elements in the reverse order. We are trying to build the suffix now, and we are doing race will be minimum of race comma c, the current suffix value, plus prefix of j minus 2. We are deleting the j minus 1th element, so the value will be j prefix of j minus 2 plus the current suffix value. Okay, and we are doing answer plus equals to race. The overall time complexity of this algorithm is around order of n log n, because we are sorting this thing. If you have any doubt in any part of the code or explanation, you can always ask in the comment section. I will try to reply each and every comment. If you find this video helpful, please like the video, subscribe to the channel, and also share among your peers. Thank you.